Hey guys, I'm back with the second part of your day one notes. Again, I just wanted to start off by reiterating that we just found out that the inverse sine function can only spit out angles between negative pi over 2 and pi over 2. Quadrant 1 and quadrant 4 angles. Those were the only angles that survived the cut of his graph. So you'll see that I draw this picture a lot. The inverse sine can only spit out angles in quadrant 1 and quadrant 4. And that's kind of like in one, what is the word I'm looking for? Consistent or cohesive, I should say. One band together stretch. Like I can't go this way to get to my quadrant 4 angles. It's from here to here, okay? So again, if you take the inverse sine of a positive ratio between 0 and 1, we saw that it's going to spit out a quadrant 1 angle. If you take the inverse sine of a negative ratio between 0 and negative 1, it's going to spit out a quadrant 4 angle. This is how the inverse sine trig function works. Because in some of the problems, you're not going to be able to use your calculator when they ask you to find exact values. So you have to think like the function, okay? And this is how the inverse sine function thinks. It can only spit out angles between pi over 2 and negative pi over 2, all right? And I meant to go back on your notes and fill in your cheat chart. This was like on the back of the front of the notes that I kind of skipped, but just to keep your cheat chart kind of up to date, we are going to say that the inverse sine of a positive ratio spits out a quadrant 1 angle. So that answer would have been an angle in quadrant 1. The inverse sine of a negative ratio between 0 and negative 1 would have spit out a quadrant 4 angle between 0 and negative pi over 2. So this is how the inverse sine works. Again, it's never going to spit out a quadrant 3 angle because those are angles that don't survive the cut of any of the inverse trig functions graphs. I don't want to cross off quadrant 2. Quadrant 2 might not have survived the inverse sines functions cut, but he survives somebody else's. So he's not 100% off limits like quadrant 3 angles are, okay? So right now the inverse sine works like this. All right, let's practice some examples. Now, I made a cheat sheet for you. Just kind of back my camera out for a second. So I just kind of gave you some important, degree and radian equivalencies. Remember, pi over 6 is 30 degrees, pi over 4 is 45, and so on. I've given you your unit circle for your quadrantals, your 0, pi over 2, pi, 3 pi over 2, but I marked it as negative pi over 2 because that's more so what we're going to use them for. And then all of their ordered pairs. Remember, all of the x's represent the cosines of these angles. All of the y's represent the sines of these angles. All right, I gave you your special right triangle side length relationships in case you want to what's the sine of a 30-degree angle? Sine is O over H. It's 1/2, and you can whip that up pretty quickly. All right, then I've even given you what I think is going to be the most important. I've given you the sines, cosines, and tangents for your 30s, 45s, and 60s, and then some of your quadrantals. I would say the most important quadrantals that survived each one of their cuts. All right, so I've given you basically a really nice cheat sheet that you should be able to use, okay? And then I've also given you down here, don't forget that we have all students take calculus. The sine, cosine, or tangent of an angle in quadrant 1 all get you a positive ratio in quadrant 1. Only the sine ratio is positive for angles in quadrant 2. Only the tangent ratio is positive for angles in quadrant 3. And only the cosine ratio is positive for angles that land in quadrant 4. And also, all right, and then I just wanted to remind you, every trig function gets you a positive ratio in 2 quadrants and a negative ratio in 2 quadrants. So the sine of an angle in quadrant 1 or 2 is going to get you a positive ratio. The sine of an angle in quadrant 3 or quadrant 4 gets you a negative ratio. The cosine of an angle in quadrant 1 or quadrant 4 gets you a positive ratio, but the cosine of an angle in quadrant 2 or 3 gets you a negative ratio. And remember, these are the irregular trig functions, not the inverse. This is how the regular ones work. All right, the tangent of an angle in quadrant 1 or quadrant 3 gets you a positive ratio, but the tangent of an angle in quadrant 2 or quadrant 4 gets you a negative ratio. So every trig function has ratios that are positive in 2 quadrants and negative in 2 quadrants. And this is going to be important when we start using the inverses and you have to switch to an equivalent quadrant. If you you'll see what I mean, okay? And then again, this is gonna be your big inverse trig function cheat sheet, okay? Quadrant 3 angles do not come out of the inverse trig functions, and then this is what happens to your inverse sine, cosine, and tangent, whether the ratio is positive or negative. I'll go back over this. Right now, we just know that the inverse sine of a positive ratio gets you an angle in quadrant 1, and the inverse sine of a negative ratio gets you an angle in quadrant 4. That's the only one we've learned so far. All right, let's try some examples. Okay. All right, so let's say you were asked, let me move my camera in again. Okay, let's say you were asked to find the exact value of. So usually when they say the exact value, they don't want you to use your calculator. Now there are some ratios that are better than others and some angles that are obviously better than others, all right? So normally if they're gonna ask you to find an exact value, these are gonna be your special ratios like 1/2, root 3 over 2, root 2 over 2, root 3 over 3, root 3, ones, zeros, negative ones, and it's gonna be like your angles that are either a quadrantal like 0, pi over 2, pi, 3 pi over 2, whatever it is, 2 pi, and then your pi's over 3, pi's over 4, pi's over 6, and stuff like that, your special angles. All right, well, remember, let's just break this down. This is the inverse sine, right? So a ratio of 1 goes in, and the answer to this is an angle. So the inverse sine of 1, right? So just remember, the inverse sine, I always do this, will only spit out angles in quadrant 1 or 4. Angles between pi over 2 and negative pi over 2. So the answer to this question is somewhere between pi over 2 and negative pi over 2. So they're asking you, what angle does this equal? That's the answer to this question because the inverse sine's answer is an angle. So I kind of turn it around back into the original trig function and I turn into, okay, so what it's really saying is the sine of what angle would have had a ratio of 1. So what angle could you have taken the sine function of that would have had a sine ratio of 1, right? And again, this angle has to be something between pi over 2 and negative pi over 2. So guys, the sine of what angle was 1? It's got to be something either special like pi over 6, pi over 3, pi over 4, or one of your quadrantals. Well, in the world of sine, if the ratio was 1, that was a quadrantal. Who had a y-coordinate of 1? Do you remember? Well, if you remember, right here is the point 0, 1. The y-coordinate is 1 right there. So the sine of pi over 2 had a ratio of 1. So the angle that makes this equation true is pi over 2. And pi over 2 is an angle between pi over 2 and negative pi over 2. So the answer to this question is pi over 2. That's the angle that the inverse sine function would have spit out, okay? It is the sine of pi over 2 that would have had a ratio of 1. And as long as pi over 2 is an angle between here and here, it can be an answer to this question, okay? Now again, on my cheat sheet, I tried to give you all of your answers. So the sine of what angle had a ratio of 1? Here's a ratio of 1. It was the sine of pi over 2. Pi over 2 is your answer. So again, I tried to give you like your cheat sheet here, all right? Perfect. Now again, you can even ask your calculator this one because it's a quadrantal, so it should be able to give you the exact answer, and the fact that the answer is not ugly. So if you took, I'm in radian mode, second inverse sine of 1, hit enter, it gives you 1.57. Well, guess what? Do you know what pi 3.14 divided by 2 is? It's 1.57. It doesn't give you the radian measurement in terms of pi. It gives you the radian measurement as a decimal. That's why it's not technically exact. All right, because you'd have to round that. All right, but the answer is pi over 2. Let's try another one. What is the inverse sine of negative 1? So remember, a ratio goes into the inverse. The answer to this is an angle. And again, it has to be an angle between pi over 2 and negative pi over 2. Those are the only angles that this function could spit out. So I like to turn it around the other way. Okay, so the sine of what angle would have had a ratio of -1. So what angle between pi over 2 and negative pi over 2 had a sine ratio of -1? Well, guys, if you know, looking at y coordinates, because that would be the sine ratio, this point right down here is 0, -1. The y coordinate is -1. So what angle was it that had a sine ratio of -1? It's negative pi over 2. So the answer to this one is negative pi over 2. Okay? Now, you could say, well, 3 pi over 2 would work because 3 pi over 2, you're right, but you have to understand, 3 pi over 2 is not an angle in between pi over 2 and negative pi over 2. 3 pi over 2 is an angle that he is incapable of spitting out because 3 pi over 2 didn't survive the cut of his graph. Only negative pi over 2 did. All right, so even if you look at my cheat sheet, the sine of what angle was -1? Well, the sine of what angle had a ratio of -1? It's negative pi over 2. Okay. All right, look here. Now, those were quadrantal ratios, 1 and -1. So those were a little bit easier in the sense that it had to be like a pi over 2 or a negative pi over 2. All right, look here. The inverse sine of root 3 over 2. All right, so you plug this ratio into the inverse, and the answer is some angle. Not any angle. It's got to be an angle between pi over 2 and negative pi over 2. Well, guys, we do have a clue. We know that if you take the inverse sine of a positive ratio, then we already know that the angle has to be in quadrant 1. So the answer to this is some quadrant 1 angle. So does anybody know the sine of what special angle had a ratio of root 3 over 2? Was it the sine of a 30, 45, or 60? Anybody remember? Was it a pi over 6, a pi over 4, or a pi over 3? Well, if you go to my cheat sheet, or even your little triangle, who had the root 3 over 2 ratio, which sine of what angle had root 3 over 2 as their ratio? Pi over 3. So the angle in quadrant 1 that this inverse would have spit out is positive pi over 3. That is the angle that would have had root 3 over 2 as his ratio, okay? And again, if you ask your calculator, what is the inverse sine of second root 3 divided by 2, close it, hit enter, it tells you it's about 1.04 radians. Well, guess what pi divided by 3 is? It's 1.04. What is pi divided by 3? Ooh. Pi divided by 3, it's 1.047. That is the answer to this question. If you plugged this ratio into the inverse sine, it's going to spit out pi over 3 as the angle, okay? All right, what's the matter? All right, hurry up, go ahead, get us now. You just had your Pringles. Stop, we're going to eat dinner soon.
No, that's like
He already got a thing of Pringles.
No.
Sorry. All right, so if you had, what's the answer to this one? If you take the inverse sine of -1/2, right? So we know if you take the inverse sine of a negative ratio between 0 and -1, then it's going to spit out not just any angle, but a quadrant 4 angle, right? It's got to be an angle between pi over 2 and negative pi over 2. And when the ratio is negative, we know that's a quadrant 4 angle just off the graph that we kept. All right, so some quadrant 4 angle between 0 and negative pi over 2 is the answer to this question. Well, I kind of turned it around. The sine of what special angle would have had a ratio, I just do it as 1/2 first, right? Don't worry about the negative part. We already know it's a quadrant 4 angle. Yes, it's supposed to be negative, but just really, who had a 1/2 ratio? What angle? Well, do you remember the sine of what special angle was 1/2? It was pi over 6. So the answer isn't pi over 6 because pi over 6 is not a quadrant 4 angle. So what angle between 0 and negative pi over 2 makes this true? Not pi over 6, it's negative pi over 6. That's the angle that we would need to make this true, okay? All right, so again, you have to think like the function. You can only give me these angles as answers, okay? All right, look here. Look at example 2. Find the exact value of each of the following composition functions. I added an example just to give you another example. All right, so look here. Well, think about what inverses do, right? They cancel each other, right? So like adding and subtracting undo each other. Multiplying and dividing undo each other. So what should the inverse sine function and the sine function do to each other? They should cancel. Absolutely 100%. So look here. Look what the answer is. If you take the sine of an angle, the answer is a ratio. When you take the inverse sine of a ratio, the answer is an angle. So yes, the inverse sine and the sine should cancel out, and this angle should be our answer. But it's only allowed to be your answer if that's an angle that the inverse trig function, sine function, was able to spit out. Remember, the inverse sine function can only spit out angles between pi over 2 and negative pi over 2. All right, so is pi over 8 an angle that would have landed in quadrant 1 or quadrant 4? If it is, then you can say he's your answer. All right, so now, I'm sorry, my son's having a tantrum. Okay, sorry, he couldn't have his eat snack of the day. All right, so now, pi over 2 and negative pi over 2. As long as pi over 8 is an angle that lands in between pi over 2 and negative pi over 2, you can say he's an answer. Well, think about it. If you needed to turn this into something pi over 8, well, I'd have to times this by 4, right? So times the top by 4. 4 pi's over 8 is pi over 2. So does 1 pi over 8 land in quadrant 1 then? Absolutely. If this is 4 pi's over 8, then 1 pi over 8 must land in quadrant 1, and therefore he can be your answer. So pi over 8 is your answer. So I know this is supposed to be a really simple problem. You just cancel them out and keep the angle. Yes, but you have to make sure that this angle is an angle that could have been the answer. Because hint, hint, wink, wink, sometimes they give you angles that it wouldn't be able to spit out. And then you're gonna have to convert it into an angle that it could have spit out, okay? So just be careful. So yes, these are supposed to be easy problems, but you have to make sure that they're not trying to trick you. All right, so look at this one. What is the answer to the inverse sine of the sine of negative 2 pi over 9? So again, you have to understand what this question's even asking. We go inside parentheses first. First, you take the sine of this angle. So the sine of this angle, the answer is a ratio. Then you're going to take the inverse sine of that ratio, and the answer is an angle. So yes, the inverse sine and the sine should cancel out, and this angle should be our answer. But you have to make sure that this angle is an angle that landed between pi over 2 and negative pi over 2, and it's an angle that the inverse sine would have been able to spit out. All right, so let's take a look, right? It has to be in between pi over 2 and negative pi over 2. Well, we're working in the world of pi over 9. So what do you times 2 by to get 9? 4.5, right? So times the top by 4.5. So this is negative 4.5 pi over 9. And the same thing over here, times the top and bottom by 4.5. This would be 4.5 pi over 9. So if this is 0 to negative 4.5 pi over 9, does negative 2 pi's over 9 land in quadrant 4 before you get there? Yes, which means negative 2 pi over 9 is an angle that this trig function would have been able to spit out, because negative 2 pi over 9 is a quadrant 4 angle. So you are perfectly okay with saying the answer to this problem is negative 2 pi over 9. He is definitely an angle that landed in quadrant 4 that this function would have been capable of spitting out, okay? All right, now look here. So they kind of got you in a rhythm, right? The sine of 5 pi over 8 would be a ratio. The inverse sine of that ratio, the answer is an angle. So they want you to do this and say, yep, 5 pi over 8, that's my answer, I'm done. Hold the phone though. Does 5 pi over 8 land in quadrant 1 or 4? Is he an angle between pi over 2 and negative pi over 2? Well, guys, right now, we have pi over 2 and we have negative pi over 2, right? If we're working in the world of pi over 8 again, right? If this is pi over 8, well, how many pi's over 8 make pi over 2? That would be 4 pi's over 8. Well, guess what? If this is 4 pi over 8, then 5 pi over 8 is actually a quadrant 2 angle. And is the inverse sine capable of spitting out a quadrant 2 angle? No. So this is where we're going to use that cheat chart come in handy, right? the sign gets you positive ratios in quadrant 1 and quadrant 2, and it gets you negative ratios in quadrant 3 and quadrant 4. So right now, we can only find answers here and here according to the inverse, right? So that means that the sine of an angle in this quadrant and the sine of an angle in this quadrant that had the same reference angle as this one, they have the same ratio. So you're going to take any quadrant 2 angle that would not have landed in his range or domain, an angle he would not be able to spit out, and you're going to convert it into his equivalent quadrant 1 angle. Okay, so we have to convert this angle into what would have been equivalent to him in quadrant 1. So guys, if this is pi over 8, here's 8 pi over 8. Who's your reference angle in between 8 pi over 8 and 5 pi over 8? It's 3 pi over 8, which means a 3 pi over 8 in quadrant 1 would have the same sign ratio as 5 pi over 8. So his equivalent answer that the inverse sign would be capable of spitting out is 3 pi over 8. So the answer to this one is 3 pi over 8. And again, those are the hardest ones because those are the ones where they're trying to trick you. So if it had been an angle that landed in quadrant 3, well, the inverse sign can't spit out quadrant 3 angles, but his equivalent angle, a negative ratio, would have been in quadrant 4. So you would have converted this one into a quadrant 4 angle that he would have been capable to spit out. Okay, so again, these are where they're trying to trick you. Yes, these are supposed to be just cross them out and keep the angle, unless they're giving you an angle that he is incapable of spitting out. And 5 pi over 8 is a quadrant 2 angle. It is not an angle that he could have spit out. So you had to convert it to his reference angle in quadrant 1 that it would have been able to spit out. Okay, all right, look at here. Find the exact value, if any, of each composition. If any means maybe there's not a definable answer to these problems. All right, let's digest it. So the inverse sign, you take the inverse sign of a ratio and you get an angle. Then you take the sign of that angle and the answer is a ratio. So yes, the sine and the inverse sine should just cancel each other out and the answer is your ratio. You just have to make sure, is that a ratio that can come out of the sine function? Remember, ratios between 1 and -1 are who survived the cut, right? So only ratios for the sine function are between 1 and -1. So as long as 0.8 is between 1 and -1, that's your answer, and it is. Okay? All right, look here. The inverse sine of that ratio would have been an angle. Then you would take the sine of that angle and the answer is a ratio. So what should the sine and the inverse sine do to each other? Cancel, and you're just left with this. But here's the problem. Can you take the sine of an angle and get a ratio that is bigger than 1 for the sine function? No, the sine function only has ratios between -1 and 1. So that means that this was never a ratio that you would have been allowed to plug into the inverse, and there's no angle you could create for it. All right, so that means that the answer to this one is undefined because that's not a ratio that is defined by the sine function or even the inverse sine. Okay, so again, they are trying to trick you with some questions. So we only want angles between pi over 2 and -pi over 2, and we only want ratios between -1 and 1. That's how the inverse sine is built. All right, and then the last one says just find the approximate value of each of the following questions. If they say approximate, you're allowed to use your calculators. Just make sure your calculator is in radian mode because normally they want the answer in radians. All right, and that means you're probably going to have to round your answer to, like, I think they say 4 decimal places. All right, let's practice. All right, so if you take the inverse sine of this ratio, right? Well, first of all, we already know the inverse sine function will only spit out angles between pi over 2 and -pi over 2. And again, if you take 3.14 and divide it by 2, that's about 1.57 radians in its rounded version. And then that's -1.57 radians, okay? So if I take the inverse sine of a positive ratio between 0 and 1, and it is, 1/3 is between 0 and 1, we already know the answer to this is some quadrant 1 angle. So it's some angle between 0 and pi over 2 or 0 and 1.57. So let's ask our calculator, what is the inverse sine of 1 divided by 3? And I'm telling you, it's going to say something between 0 and 1.57, some quadrant 1 angle. And it does. It's about 0.3390 radians. And that's the angle. And again, it's a quadrant 1 angle. All right, what is the inverse sine of negative 1/4? Well, again, we already know. If you take the inverse sine of a negative ratio, again, as long as it's between 0 and -1, and it is, if you take the inverse sine of a negative ratio, we already know the answer to that is a quadrant 4 angle. It's some angle between 0 and -pi/2, or 0 and -1.57. So ask your calculator, because again, these aren't special ratios, so they're not special angles. They're not 30s, 60s, and 45s and whatnot. So let's take the inverse sine of -1 divided by 4, hit enter, and again, I'm in radian mode, and it's going to be something between 0 and -1.57. And it is. It's -0.2527. And that is definitely an angle that would have landed in quadrant 4 between 0 and -1.57 radians. All right, so that's what you're going to be asked to do on the first day. I'm just giving you the inverse sine to get used to. And then we'll introduce the inverse cosine and the inverse tangent. But it's going to be very, very similar. There's going to be angles that survive their cut, and those are going to be the only angles they're able to spit out, okay? All right, so again, good luck on your homework. I know AP testing is starting, so I'm going to give you lots of time for your homework to be due. And you can just kind of get it done whenever you can. All right, sorry these videos got so long, but like I said, this is very intricate, and I just wanted to make sure that everything was explained to you very thoroughly. All right, good luck, and as always, always reach out to me if you need any help, and I will be more than happy to help you. All right, good luck.